You might remember the idea of partial fraction decomposition from pre-calculus, and you might have remembered, you probably asked yourself why you're learning this. And today I'm going to show you why you learned that. We're going to be integrating using that concept, and I'll show you why that makes our integrals easier. So first, let's review partial fraction decomposition, and then we will use it to integrate. So let's say we have some fraction, which is 2x plus 3 over x squared plus x. And our goal here is to split this fraction up into two fractions, and essentially that's what partial fraction decomposition is. So I'm going to rewrite this fraction as 2x plus 3 over, I'm going to factor the bottom. So let's do that. We can factor the bottom as x times x plus 1, and we can let this equal to some value a, some constant a, over the first factor, which is x, plus some constant b over the second factor, x plus 1. And you can sort of think about why this makes sense. If we get a common denominator, we need to multiply this thing by some constant and then add it to this thing with some constant to get the top. Now, to figure out what these values a and b are, we can do a little trick. We could set up a system of equations, but let's just use that trick that we learned. So what we do is we plug in a 0 into this expression, assuming this x doesn't exist. So, and the reason why I plug in 0 is because 0 makes this undefined. So you look for the number that makes this first fraction undefined, you plug it into the full expression that you have, and you pretend like x doesn't exist. So let's do that. If you plug in 0, well, this goes away, we get 3 over 0 plus 1, which is 3 over 1, so that's 3. So a is 3. Now for b, we do the same thing. We pretend like x plus 1 doesn't exist here, and we look for a number that makes this undefined. The number that makes this undefined is x equals negative 1. And so we pretend like x plus 1 doesn't exist, and we plug in negative 1. If we plug in negative 1, we get 2 times negative 1 plus 3 over negative 1. So this becomes negative 2 plus 3, which is 1 over negative 1, which is negative 1. So b is equal to negative 1. So splitting this fraction up, let me rewrite the whole thing, the different color. So as we split it up, 2x plus 3 over x squared plus x, we know is equal to 3 over x plus, actually we'll just do minus since it's negative 1, minus 1 over x plus 1. These are completely equivalent fractions. And let's actually just test it out. Let's really quickly get a common denominator and subtract these two fractions to make sure that it's the same thing. So the common denominator here is x plus 1 times x, which is x squared plus x. And to get this one to have the common denominator, we need to multiply it by x plus 1. So we need to multiply the top of that fraction by x plus 1 as well. So we get 3 times x plus 1 minus, this one we need to multiply by x, so minus x, over the common denominator x squared plus x. If we simplify the top, we get 3x plus 3 minus x, all over x squared plus x, which is equal to, we simplify again, we get 2x plus 3 over x squared plus x. So notice that when we did get a common denominator, the fractions are exactly the same thing. So let me rewrite all of this. I'm gonna just rewrite this part, and I'll talk about why we just did this. So 2x plus 3 over x plus x. Okay, so I think I remember it. We have 2x plus 3 over x squared plus x is equal to, I believe, 3 over x minus 1 over x plus 1. I hope it wasn't the other way around. I think it was this way. Now, the reason why we do this is we're able to integrate things that we aren't able to integrate otherwise. So if we want to take the integral, for example, of 2x plus 3 over x squared plus x dx, the only way for us to do this is actually to split up the fraction. And let me show you why. So it seems like a viable solution here would be to just do u substitution, but let me show you why that doesn't work. If we let u equal x squared plus x, then du would be 2x plus 1 dx, right? So it seems like we almost have it, right? But it's not, if we take du, it's not 2x plus 3, right? If it was 2x plus 3, then we'd be able to do it. But it's 2x plus 1. So there's no way for us to make this look like the top. Now, what if we try u equals x squared? Let's also try that. If we just say u is equal to just x squared, then du would be 2x. Okay, that also seems viable. Let's see if this works. Well, we know that, 2x dx. So maybe we can rewrite this as du times, so the issue actually comes right here. If we write du, we need a plus 3 right here as well, which we aren't able to get, right? And we also need a plus x, and u is x squared, right? And there's no way for us to get x in terms of u. So we notice that it doesn't work. So the only way for us to do this is actually use partial fraction decomposition. So let's rewrite this as, we know these are equivalent, right? So we can rewrite this as the integral of 3 over x minus 1 over x plus 1 dx. Now we know if we have an integral of two things, two different expressions, two different terms, we can just rewrite them as the integral of those terms separately. So this is equal to just the integral of 3 over x dx minus the integral of 1 over x plus 1 dx. And maybe pause the video here, see if you can figure this integral out. Alright, I'm assuming you've paused the video and had to go at it. Well, the integral of 3 over x dx would just be, so let's think about it. We need a function whose derivative is the integrand. So think about what function gives us that. So in this case, that function would be natural log of x, right? And we also have a 3 up there, so we need to multiply this by 3. And then for this one, we're going to subtract, again, in this case, also the natural log of x plus 1. And then plus c. Now, take the derivative of this and make sure that you get the integrand. And that's how you can confirm that your integral was correct. So let's actually do that together. If we take the derivative of the first term, we get 3 times 1 over x. That's just 3 over x, right? So let me just rewrite it as 3 over x. And then if we take the integral of this, well, it's just 1 over x plus 1. And if we take the integral of c, that's a 0. So this right here is exactly what we have in the integrand. So that's correct. So our integral is 3 natural log of x minus, I almost forgot the plus c, 3 natural log of x minus natural log of x plus 1 plus c.